Hello students, and welcome to this video on parallel and perpendicular lines. Our objective today is that we will write equations of parallel and perpendicular lines using journal notes and practice problems. So you guys have been exploring this topic for a couple of days now, and we're just going to codify this into our journal so that we have this knowledge for the future. So what we can say about the slopes of parallel lines is that if two lines are parallel, then their slopes are the same. So that's one of our conditional statements, right? So we have that statement, and then we can write this algebraically as the slope of the first equation will be equal to the slope of the second equation. Alright, so if we have lines being perpendicular, then the relationship between their slopes will be if two lines are perpendicular, what do we know about their slopes? Well, as you guys saw, there was a special relationship that occurs. So we notice that this relationship kind of holds, where if you have m1, then I said that this was 4, then the perpendicular slope would be negative 1 over 4. And this change has a special name, and we call that the opposite reciprocal. So then we can say if two lines are perpendicular, then their slopes are opposite reciprocals. And again, all that means is this relationship right here, where if I start with one number, the opposite part is the change in sign, and the reciprocal part, well, the reciprocal is when we take a number, right, and we flip it with its denominator. Normally 4 can be expressed as 4 over 1, therefore the reciprocal would be 1 over 4. So what does this mean for us? Well, it means that now, given a slope and given a point, I can create a line which is either perpendicular or parallel to some original line through that point. But to do this, we're going to use a special form of the equation, y minus y1 is equal to m x minus x1. And obviously m is your slope, and as we've seen before, x1, y1 is just a point. Alright, so now given all that, let's go ahead and get into the meat of this. Let's start writing equations. Alright, so for our first example, we're going to write the equation of a line parallel to y is equal to 2x plus 5 through the point negative 4 comma 2. So we're going to talk about the process first, and then we'll start doing it. So if you're trying to write a line which is parallel, well, the most important thing about being parallel is the fact that your slope is the same. So your first step is you want to identify the slope. And so if we look up at this line here, well, it looks like my slope, right, y equals mx plus b, is going to be 2. So m2 will equal 2. And I'm writing m2 here because this is our slope of our second line. So now that we know what we want the slope to be, I want to focus on this point here. It needs to pass through the point negative 4 comma 2. Well, if I want it to pass through that point and I know the slope, then what I can do is I can plug this into our point slope form that we just got of the equation, and that should give me my line. So now I can take my slope, which is m equals 2, and I can take my point, which is going to be negative 4 comma 2. Remember, this is x1, y1, because this is my given point, and I can substitute that into my equation. And I'm just going to rewrite this a little bit here. So I have y minus y1, and I know that y1, according to my point here, right, x1, y1, is going to be 2. So it's y minus 2 is equal to, and then I've got m, which is going to be 2, and then x minus, well, now I have minus negative 4. So it's written as minus negative 4 here, and we all know what's going to happen here. So we've got y minus 2 is equal to 2. That minus a negative becomes x plus 4. And now what I want to do is I want to get this into y equals mx plus b. So let's go ahead and distribute our slope. And so we have 2x plus 8 is equal to y minus 2. And then I'm going to add that 2 to both sides, and I've got y is equal to 2x plus 10. So my final answer here for the equation of a line parallel to y equals 2x plus 10 and passing through negative 4, comma 2 will be y is equal to 2x plus 10. Now, some of you guys are going to see some shortcuts here where you feel like you could do less work to get to the answer, and I encourage you guys to do that, right? But only after you've mastered this approach. Once you see the way that this goes for every problem, then if you encounter a problem that your tricks don't work for, then you'll have something in your toolbox for that. Alright, so now I'm going to work through example 2 and example 3, and I'm going to do these pretty quickly. So I'm going to identify the slope, and I'll identify the slope in purple here, and then I've got my point here. So I know that my m is equal to 3 over 4, and I know that my point is going to be negative 8 comma 11. So I'm going to go ahead and plug that into my equation, y minus y1, so I've got x1 comma y1 here. So y1 is going to be this negative 11. So I'm just going to go ahead and write in, regular 11. So it's a positive 11. So y minus 11 here is equal to, then I'm going to plug in my slope, right? And that's going to be equal to 3 over 4. And then I have x, and then minus, and I just plug in negative 8 here. So again, we're going to have that action here where we have that double negative. You guys need to be really careful about this. So we have y minus 11 is equal to 3 over 4, and then we have x plus 8, all in parentheses. Okay, so now we're going to distribute this 3 over 4, and we get y minus 11 is equal to 3 over 4 x plus 6, because that's 3/4 of 8. Alright, and then we're going to add 11 to both sides, and our final answer will be y is equal to 3 over 4 x plus, that's going to be 17. Alright, so for example 3, I want you guys to try this on your own, and then I will check your answer. So go ahead and try it on your own, I'll check your answer, and then I'm going to go ahead and move on to perpendicular lines now. So we moved on to the next page. And now what we're going to see is that we're going to write the equation of a line perpendicular to y is equal to 1 over 8 plus 2 at the point 1, negative 5. So again, our first step is that we're going to identify the slope. So in this case, our slope is 1 over 8, and then we're going to change the slope to its opposite reciprocal. So if we call our original slope m1 and we call our new slope m2, then we see that our new slope, well, the reciprocal means that I'm going to take the top and put it on the bottom, and take the bottom and put it on the top, and then the opposite part means that I'm going to make it the opposite sign. So my new slope is going to be negative 8 over 1, or we can write this as negative 8. And then our final step is we're going to substitute the new slope and point into point-slope form. So again, we identify our point as 1 comma negative 5, and our slope as negative 8. So I have m2 is equal to negative 8, and my point is going to be 1 comma 5, negative 5. And so we can just start plugging in. So I have x1, y1, And so I'm going to say y minus -5 is equal to -8, comma, x, and then -1. Okay, so we have that double negative happening here, so I have y plus 5 is equal to -8, x minus 1. I'll distribute the -8, so I have y plus 5 is equal to -8x, and then negative multiplied by a negative will cause it to be a positive. So now I have -8x plus 1. And so I'll subtract 5 from both sides, and I get y is equal to -8x minus 4. And so that will be my final answer. Alright, so we're going to do example 5 together, and then I'm going to cut you guys loose onto your reflections. Alright, so example 5, we have our m is equal to 1, therefore our m2 is equal to -1, because 1 over 1 swaps, and then we made it negative because it's the opposite. Then our point is going to be 4, comma, -1, and so we can plug this all in. Y minus, we have x1, y1 here, so y minus -1 is equal to, and then we have a slope of -1, and then x minus 4. Alright, so we have y plus 1 is equal to -1, and then I'm just going to go ahead and distribute in a second here, so x minus 4. I'm going to distribute the -1, and so you see that I'm distributing a negative on a negative, so that's going to cause it to be a positive. So I have y plus 1 is equal to -x plus 4, and then I'm going to subtract 1 from both sides, and I get y is equal to -x plus 3. Alright, so again, I'm going to leave you guys to do 6 on your own, and then I'm going to go ahead and switch us off to our reflection. So when you guys do your reflection, you're going to, you know what guys, instead of doing this problem, I want you to go ahead and cross this out. This won't be our reflection today. And what I want you to do instead is finish example 3 and example 6. And I still want these in point slope form. So don't do this example, instead do example 3 and example 6. Alright, if you have any questions, let me know, and make sure that you get a stamp for your reflection. Have a wonderful day. Goodbye.